managing the data is a separate process from the LLM itself.
We talk about this all the time. I do, at least dirty data in, dirty data out.
You can have it refer to the actual knowledge base, the knowledge document that it's getting from.
Regular training of LLMs also vectorizes, but it vectorizes at the token level. And what RAG adds is a vector at the chunk level.
Hey, what's going on, everybody? Today is August 29th, 2024, and you're watching the Daily AI Show live, and today we're talking about getting the best out of your RAG prompts. So if you don't know what RAG is, that's okay. We're going to go over that too, and we got the people to do it with you. So today we have Jyunmi, we have Beth, Andy, and I'm Brian. And yeah, we're going to we talked on Tuesday how this was sort of a, not really a two-part series, but on Tuesday we had a whole show. If you want to learn more and understand about fine-tuning, and when that might be something you might want to look at. We used examples from GPT 4.0, and I think we also showed 4.0 mini because OpenAI has allowed people to basically play for free. I'll put that in quotes a little bit if you can't see me, because they give you so many credits per day, and you can kind of go mess around. You can do that in, it's not the playground, it's the dashboard. But on that show, we show you some easy examples of how you could do it. They're really basic stuff, not like crazy fine tuning, but it'll get you started on there. Now, today we want to talk about RAG, and we're going to give you a definition on that. But the reason why we want to do that is to show you that there are times where a RAG system makes sense, right? There's times where fine tuning makes sense. And there's also probably a lot of conversation here about when just good quality prompt engineering is going to get you really, really far. And we sort of talked about that on Tuesday, and it'll certainly come back up today. It really is about the quality of the questions you're asking. And the better you can get at asking good questions, good, deep questions, the better your results are going to be. I don't care what system you use. So that's sort of a quick intro here. I feel like I want to jump to you, Andy, only because you've always done a really good job on the show of just explaining RAG systems, what that acronym means. And so maybe let's just do a quick baseline before we get into anything too deep here.
Sure. Well, I'll start with a definition, but then I want to tell you a little bit about the history of software applications and how we've arrived at a place where a RAG system, which uses an external database to the LLM, matches up with the way we've always built software. It also solves a lot of the problems that we have with tuning a model and then trying to use it over time. So RAG is a machine learning approach. It enhances LLM responses by dynamically retrieving and incorporating relevant data from a large database of documents during the generation process. Okay, so it's using an external database. Well, this isn't anything new. Before the internet, before we had cloud applications and everything was being done through the browser, you had local PC or Mac applications on your computer. These were all built around a database. Probably the database that we all are most familiar with is a spreadsheet. The spreadsheet is a database of rows with field values as columns. And then there's an operating software that has routines that will allow you to do operations against those data. All right. But the database that's accompanying other kinds of applications might store, for example, the content levels of a game. So if you have a game that's running on your local PC or on an Xbox, it's got a database with all of the images and content and all the paths that you can go through in that game. Or another classic example of an application was contact management database. All of my records of the people I have emails and telephone numbers and everything for. I can add data to that record. That's the database that I'm playing with. But the UI that I have on the computer screen is being run by some code that goes and fetches information from that database and then presents it on the screen. Okay, so there are these routines and subroutines that deliver the audio-visual experience or data representations. But now, with LLMs, we have a single application that doesn't need necessarily to consult with a database at all. Pretty much the entire world knowledge to date, well, with some selection bias because they had to use only what was available from the internet, is trained into that mysterious coding of weights in the many billions of artificial neurons. So what do you need a database for? And for many questions, many prompts, you don't need anything else. What's already in there is pretty complete. But you still need, in an application like ChatGPT, you still need to store and serve images from the web if it's going to retrieve that sort of thing. That's the web crawling aspect of it. Or you need to have your user account information, like am I a paid user of ChatGPT or a non-paid user of ChatGPT? So there are databases associated with that. And more importantly, with respect to RAG, you want to have specific knowledge collections that weren't accessible to the web crawlers when the training of the LLM was done. So, we gathered all that information from the open source documents, but there's a lot of things, including corporate knowledge, that's not accessible to the web. You have a firewall that doesn't let people come in and look at your corporate information. And you want, if you're going to build an LLM that's going to represent your corporate knowledge and the cultural wisdom that your company has developed over time, you want your AI co-pilots and your assistants to comprehend and apply that specific knowledge. So now, as to how LLMs work, LLMs, if they're not fine-tuned, as we discussed on the earlier show, they have to process everything at the time that you put your prompt in. Now, there's a much larger package than what you just put in to that prompt, including the system prompt that tells the LLM again what it's supposed to behave like when it's responding to a user query. So you were just yesterday, Brian, showing us the actual system prompts for Claude, for ChatGPT, et cetera, that tell the LLM what it is and what it's doing. Now it gets that block of context every time that it needs it. And they do have a method now called context caching or prompt caching, which lets you save that so you don't have to keep running it through the model every time you present a new user query. Okay, so LLMs have to get all of the context that they're going to process at the time that you're getting it your prompt. And so anything that you're going to add as context is going to be added to that prompt. So if you don't add specific knowledge content, then LLMs hallucinate and produce irrelevant information when they're asked about specialized knowledge, for example, about medicine or law or finance or private corporate information. So to fix this problem, Retrieval-Augmented Generation was introduced in 2021. That's when it was first done. This is before we had experience with ChatGPT. And basically what Retrieval-Augmented Generation does is it retrieves information that's relevant from the database, augments your prompt by adding it to the prompt, and then runs the generation inference. So that's RAG. Now there's an advancement of RAG called GraphRAG, and there was a recent announcement from Apple just a couple days ago about a very refined method of GraphRAG that advances the capability of a RAG system quite dramatically in terms of its compute speed and accuracy. And we can talk about that later, but I think it's a little too deep for this overview. And I know Brian has some excellent examples that he wants to show. So that was 2021. GraphRAG just earlier this year. So that's basically it. If you want to put that information in there, it's going to be retrieved with semantic retrieval techniques. And the major one is called vectorized semantic retrieval, or a vector database. And I can explain the details of what vector databases are and what GraphRAG is as distinct from that, but I'm going to pass it over from here if that's a sufficient introduction.
It's a phenomenal introduction, which I'm not shocked at all, because you've done it before in the show, and you were certainly one of the first people, along obviously with Jyunmi and Beth and the rest of the crew, to really help me understand and wrap my head around RAG. So yeah, I think that's a good idea, because I was about to ask you about getting into the math of the vector side, because I find that interesting, but you probably have a solid point that maybe we can punt towards a little bit later in the conversation. So I do have something keyed up or whatever, but I thought maybe, Beth, I would kick it over to you if you want to, or Jyunmi, because, Andy, one of the things you were talking about is the fine tuning. And so my if I was going to just ask a general question here back to the group, I'd be like, okay, great. Why tell it to go over to that RAG system if I can just fine tune it directly into the LLM? As you were saying, Andy, like it already does that really well. So why don't I just fine tune it with my company knowledge right into the LLM and save myself the pain of maybe getting the wrong answer on a RAG? So I think that would be a general question. So maybe somebody wants to do that one.
Shall I answer? My first point would be managing the data is a separate process from the LLM itself. So if you're going to have to retune your model every time you change your data, that means you're constantly fine-tuning your thing, and that's an expensive compute process. It has to run through the entire model with the new data every time you fine-tune it, and there's a cost to that. So, however, if you have your database over here as a vector database, you can change, update, add data, etc., and then at runtime, the RAG system goes and grabs the latest data that's relevant and brings it back to the inference process. So that's the main reason in my mind why you wouldn't want to do fine tuning. It's like you're adding an enormous amount of effort to your whole process.
I'm going to jump on that and say, so you talked about the vectorization. Regular training of LLMs also vectorizes, but it vectorizes at the token level. And what RAG adds is a vector at the chunk level, right? So you're getting chunks of your corporate data, your corporate mission, your corporate policies. You're getting chunks of healthcare outcomes. A while ago, we talked about OpenAI's partnership with Color Health, and that they were using a specialized version of, I think, for the model GPT-4o. The specialized version of the GPT-4o model is associated with the RAG data of Color Health. So yeah, like that's part of the key distinction between wanting to fine tune so that it has your voice, or wanting to add a RAG system so that it has like your knowledge, your data, your specialized chunked information.
I have a quick follow-up question. See, I don't know the answer to this, Beth, but I feel like you just kind of said something that made me think of it. Okay, I talked about it yesterday. Not strawberry, the Q-star model, not that. The word literally strawberry that has the letter. I joked about this yesterday because there's some funny memes and things going on around. When you ask ChatGPT, I don't know if you did it right now, if it would do this, but you ask it and you say, how many R's are in the word strawberry? Well, it's 3, not 2. But there is some really long versions where it struggled mightily to do that. And Beth, based on what you're saying, that is a difference between, let's just give 2 hypotheticals. One is you just ask the LLM to tell you how many letters in a word. 2 is there's a RAG system that has a dictionary in it. If you're using the RAG system and there's more context around it, you're saying, hey, the RAG system probably going to do a better job of telling you how many about that word because it maybe wasn't tokenized. We wasn't split in the middle, maybe.
Almost. Yes, and almost.
Okay.
So what you're asking is, first, you're asking an LLM to do math. And what the LLM needs to understand is that it needs to do a counting function, which is not a next word, next character, next token prediction function. And so until fairly recently, most LLMs did not take that question as, I should spin up a program to count these. The other thing that you're asking the LLM to do is to take 2 separate parts or 3 separate parts. I think strawberry is 2 tokens, and then not just count the last one, right? Because it's real, like it's doing it in order. It actually doesn't have a function where it goes back and reads it again. When we say go back and read it again and count the R's, it's answering the next predicted response to that. And as we know, the next predicted response is not only mathematically correct. It's not often mathematically correct. It's not probably mathematically correct, right? And that's a hard concept to get. And so we're like getting around that with this data chunking, because we don't need to know we're not asking you, the LLM, to judge the words that are in this. We're asking you to look at the chunk, and is that relevant? Is that coded as relevant? So often when you talk about RAG systems, you're talking about metadata, right? Like what were the tags around it? What was the extra metadata that would help the RAG system when you ask the LLM? And the LLM is going to go talk to the RAG system, bring back the data. Did you make it easy for the LLM to do that? That was a long answer to your question.
Yeah. No, that's a good answer. I was wrong. Like I'm glad you got me right on that, because the first part of what you said, I was like, oh yeah, no, okay, that totally makes sense. So I am glad I asked it, because as we always say in this show, like we're not all coming in here with all the answers. The whole reason to do this show is so that I can learn from Beth and Andy and Jyunmi and Carl and Robin and Aaron. So I love this, because I think everybody gets to learn along with us. I'm sure other people have that same question. So
before we move on to the next section, I did want to make sure that we went over one of the key elements of why you would use a RAG system, right? And Andy's talked about updating information quickly, the reducing costs, things like that. But I think a key feature is transparency and being able to cite the sources, right? So if you fine tune, that knowledge is all in there. You ask the LLM, it's like, oh, where is this from? It's going to say me. I'm telling you this is where it's from, right? But
or it'll tell you, oh, this is from this citation.
Right. Yeah.
It knows that's what you want, but it's not real.
Exactly. But with RAG, you can have it refer to the actual knowledge base, the knowledge document that it's getting from. So just as a quick example, AIinBusiness. So anyone who's in AI knows that AIinBusiness is where all the research papers are, and this is a great resource to actually have access to the research papers for whatever field. Now, if you were to build a chatbot or LLM or anything like that, a system to access that information, you want to know which research paper you're referencing or what source citation you want, and be able to pick out from that exact document. So I think transparency in the fact that you know what all the documentation is, and you're able to source the specific documentation, is a key feature. One of the things that is under question when it comes to using AI is that level of transparency, the whole black box, the mysteriousness of where the information's coming from. And there is moves towards that. Anthropic released, how a system to better look at their own AI. But I think with RAG, being able to adapt and the flexibility of changing and having that transparency and being able to cite those sources makes a really strong argument to use RAG in most instances, or definitely different than when you would use fine tuning.
And I think maybe before I show the example I have, I'm going to actually share this tab instead. And I only bring... there we go. I'm having issues with sharing the screen. I should have this nailed by now. I'm only bringing up Pinecone because Pinecone is one of many, let's say, companies, but it's one of the more popular ones I'm aware of that does, it says here, Pinecone serverless lets you deliver remarkable Gen AI applications faster. And if we just go here, it talks about start and scale seamlessly, create an account and your first index in 30 seconds, then it'll upload a few vector embeddings from any model or a few billion. Then it says you can search through them and you got low latency, vector search to retrieve relevant data through search, RAG, recommendation detection, other applications, and it's letting you scale. So why am I bringing up Pinecone? Well, really just to talk that it's been my experience, I don't know about the rest of you guys, that there are pretty broad examples of RAG. Like when you say RAG, there's like what seems to be very quick, not necessarily the best version of it. And then it says, I'm done. And you're like, I don't know, that was almost too fast. It was like uncomfortably fast. Like how could you have vectorized everything that quickly? Not to say Pinecone is or isn't or whatever, but I think it's worth just bringing up that there are, in my experience, there are different levels of quality RAG systems. I guess let me just stop there. Do you guys see the same? Have you seen the same where something claims it's RAG and it's like, I mean, I guess it is. It's a database somewhere, but then I've seen higher quality ones that tend to give much better results consistently and with low latency as well.
I'm going to say yes. Often RAG is used as our LLM doesn't hallucinate, right? But it's an LLM. Like you have to form the RAG system in a way that makes finding the accurate answer both the most probable and the least resource intensive, and like the easiest, right? Is the easiest downhill is to just go and grab the thing. And if you have not done that, that can lead to hallucinations, because because LLMs are always hallucinating. We just don't call it hallucinating when it's hallucinating correctly, right? Like, it is not ever looking at the tokens and saying, is this the right token? That's code, and that's RAG. But it's often, RAG is often used to say our system doesn't hallucinate. And the people who are, like when you listen to the people who are developing LLMs, there's a little disagreement in terms of whether like hallucinations are just a thing and we're just like the developing systems like RAG, or whether they're saying hallucinations are going to go away, and that is going to be higher reasoning and more accuracy in terms of being able to go and check, which is a RAG system currently.
Yeah, I'll answer your question in a slightly different way, which is just pure vectorization of the data doesn't necessarily bring back only relevant information. It can fail because the clustering of concepts that's available in those vector embeddings is not necessarily pure. Like, it's going to be fuzzy in a way. And so what GraphRAG and other techniques are doing is adding structure to the database that has more rigidity to it. And in the case of directed, what is it? Directed acyclic graph database, which is what the Apple thing is about. Not only does it have structure, like creating an ontology or taxonomy inside the data prior to the LLM getting the data, it knows where it is in the concept space within a graph. And so it can say, oh, this concept is linked to this concept. So maybe because of this word in the query prompt, I'm going to bring back these two things that a pure vectorization wouldn't do. And the Apple one has directionality, meaning that there's only a one-way flow through that graph. And what the Apple deal did was, not only does it make for really, really accurate results, and I have some statistics I can share with you on that, but it allows for parallel processing, because no one path comes back to the same point and becomes sort of, circular. You can run different starting points through the LLM's deep neural network and advance the speed of compute, but you're going to prune off all those things that are irrelevant, so that in the next pass of tokens, you don't use a lot of the ones that you've already determined are paths that don't contain any relevant information. So you get an efficiency gain with that methodology called directed acyclic graph database. And that's the main advantage that they produced with that. And dramatic improvement in the speed and accuracy. I think more than 90 times as fast as a typical RAG system is what the Apple system came out with something like a 50% improvement in accuracy.
That's amazing. I think too, I don't know that it would necessarily apply to GraphRAG, but worth mentioning at least. I'll go way back to a simple example. If you're building a custom GPT and you want to add a knowledge document to that, we could see that as a very basic example of a RAG system. I'm adding a document. I needed to bring in that information into the use of my custom GPT. I do this all the time. I will tell you, just from learning and getting, doing this a lot, excuse me, that it matters how you organize the data to begin with. So I have just found out through trial and error and also literally asking ChatGPT what it prefers and other ways of doing this, that it'll read a document, it'll read CSV, it'll read a JSON, it'll read a lot of things. What it tells you it prefers, and what I have definitely seen a difference in comparing apples to apples, is Markdown. And so Markdown is just basically like, if you don't know what Markdown is, it's just like an H1 header would be hashtag and then the words, that'd be an H1 header. If you want to do a bullet point, that would be a dash, and some other basic ways of doing it. It's essentially an outline. In my experience, I have found superior results just in a basic application like a custom GPT, where I might only have, less than 10 documents in there, if I first organize it in a way that's structured and is in Markdown. Now, I don't know if that scales necessarily to Pinecone, and definitely I don't know if it does to Graph, but it's something to consider that, we talk about this all the time, I do, at least, dirty data in, dirty data out. And so that would be a good example to me of it does matter that you don't just dump a ton of data in there that's maybe unstructured, because it might have a hard time compartmentalizing different parts of it. Now, maybe with Graph and what you're talking about it being nodes versus vector, that may be something of the past. I don't know. That's kind of interesting, because maybe it doesn't need us to do as much work up front, because it's able to do the work on the back and make conceptual connections between stuff. But it's something worth bringing up for sure, especially if you're working with custom GPTs. I will tell you right off the bat, you're going to have a lot of success if you put something in Markdown. And just really quick, if you're like, Brian, I don't know how to do that, it's okay. Take a Google Doc that you've created and download and upload it into ChatGPT first, and say, can you turn this into a Markdown file for me? And it'll do it for you. Then download that and use that as your knowledge. So you don't have to do the work. Just go ask ChatGPT to turn whatever you have into a Markdown file, and then it will then go use that. And in my experience, it's been better. Okay, I want to share this so then we can get back to this deep dive stuff too. And so what I did was, as just a thought experiment to help with today's show, I went into Chatbase. Chatbase is a company that, a while back on AppSumo, over a year ago, they had sort of a lifetime, we're trying to raise money or whatever. And I think it was $150. You would get a lifetime subscription to Chatbase. So I popped back in there and I thought, let me create something really, really quick. So I grabbed what accounted for 6 million characters, which is about 1.2 million words, based on what I could get ChatGPT to tell me, because I wasn't sure, which is comparable to the entire anthology or all the books of Harry Potter. If you just want to conceptualize how big information, all the books of the Harry Potter series squished together. I, in about 30 seconds to a minute, went and grabbed that much of our transcripts from our previous shows and threw it into Chatbase. And fairly quickly came back and said, it's been vectorized. What do you want to ask about it? So what I want to share really quick is on the screen is a comparison. And there's some other things we got to leave out of this conversation because it gets into the weeds a bit. But I just want to show a side-by-side comparison of how you would go about prompting to get the best out of a RAG system and an LLM at the same time. So I'm not going to scroll on both sides of these. All I will tell you is on the left, I am using GPT 4.0, and on the right, I'm using Claude 3.5 Sonnet. Okay, so that's the LLM on the background. And I've already told you that the RAG, the database is roughly 1.2 million words of transcripts about our AI shows. So lots of AI stuff in there, weeks and weeks and weeks of content. And so I always like to start with this question, which is explain how zero gravity isn't a thing. Because I was just joking before we went live. That's something I didn't quite comprehend as well as I should have. Way into my 40s, I'm 46. Thank you to Neil deGrasse Tyson for explaining that it's just really about speed and falling fast and never really quite catching up to the Earth. And that's why you were sort of hovering there in it. But there is no zero gravity, or at least you would have to be way, way far away from big objects for that to be a thing. So why am I asking that? Well, because it has nothing to do with AI. It has nothing to do with any shows we've done, except I'm kind of breaking that mold now if we use this transcript in the future. I've kind of screwed us because now I'm talking about it on one of our shows. That's a meta problem. So basically what you're seeing on the right is 3.5 going, hey, right off the bat, I apologize. I don't have any information on that, but I'll answer your question. And it does. Okay, great. So the same thing on the left, only I don't like the answers as well. So I'm only going to scroll from here on to the right because it'll take way longer. So then I'm just going to go through some of the questions in increasing complexity to show you how I'm trying to use this system to use both areas of expertise, the LLM as well as the RAG. When did the subject of RAG systems come up? Also very meta because we're talking about it right now, but we've also done previous shows about it. Andy has imparted lots of wisdom in RAG systems. And so this might even be an Andy quote right here. I'm not sure. It's not attributing it to him, but it's a direct quote out of some of our transcripts. It says the speaker, we'll say it's probably Andy, goes on to explain the RAG systems are often built using tools like LangChain and involve retrieving information, so on and so forth. Okay, so it's pulling back information from the RAG system. When did we talk about Denmark? Because we have talked about Denmark in a show, and it was my mistake. It wasn't part of the training data. But this is good, right? Because it says, hey, I apologize. I don't see any mention of Denmark. So actually, it was a mistake that actually worked out for this explanation because it didn't try to lie to me. It didn't try to hallucinate and just say, yeah, you guys totally talked about Denmark. And I would be like, we did talk about Denmark, only to find out that that knowledge is not in the system. That transcript from the Denmark show never made it in there. So it's good that it's actually telling me, I don't have it. What do you want me to do next? So I'm like, okay, never mind about that. How about AI cookbooks? Because I knew that was in. I went and checked. And now we're getting a whole bunch of information. AI cookbooks. Okay, let's get into the more advanced stuff really quick so we can get back to our conversation here. Great. Can you teach me more about AI cookbooks based on this information? So now what am I doing? I'm saying, I just had you pull something from our database, but now I want you to expand on it. Basically, I'm saying, hey, go use your LLM knowledge and tell me more. So that's what it does. And it's before it was using transcripts and it's using knowledge, but also beyond direct quotes, it's using concepts and ideas that we brought up on the show to help inform how it's going to expand into business application, which we've definitely talked about, resources and customization and custom learning. Okay, now we get to this big old prompt here. And I actually had ChatGPT help me write this prompt because I wanted something that really dug in. And so in this particular case, I'm saying, hey, I want to create a AI Literacy 101 course. That was specifically the name of one of our shows. So I knew I was telling it to focus, right? But what I'm saying is like, I need to create a course for high school students, so on and so forth. Could you provide a detailed lesson plan that includes key points and quotes from relevant podcast episodes to illustrate these concepts? Additionally, please expand on these points with clear, age-appropriate explanations, suggested and engaging, interactive, so on and so forth. Okay, so Sonnet does a great job with this. Hey, certainly, I'd be happy to help create this. And what it does, without us diving into all of this, is it does create an entire lesson plan, which you would expect ChatGPT to do, but it's bringing in knowledge from our discussion, our show's discussion about AI Literacy 101, and using that as a base to create more content. So right away, you can see how this would be super valuable for onboarding, for language management systems within a company. Hey, go do this thing on this topic that I want you to know about, but also expand on it based on the power of the LLM. So we'll just go real quick to the last one here, or last two. I said pick 3 or 5 universal themes. It did. It decided AI literacy and education, process documentation and optimization, where it's again pulling in direct quotes from our shows. It did data management and cleansing. You know, I'm a big one on that one. In fact, from the transcripts, quote, clean up your data. Like he said, clean up your data. I love that quote, by the way, because it was probably Jyunmi saying like, Brian just said this, which is why it makes me laugh. Goal-oriented implementation. And then finally here, just so we can wrap up, just something different. Because I had used the example of how many words conceptually is 1.2 million, and it said, yeah, about the whole Harry Potter series. I'm like, okay, I was already thinking about Harry Potter. I'm not actually a big Harry Potter fan myself, but I said, hey, if I was a user at a company, how might I do this to get a great answer that I understand really, really well? It's going to help it be sticky for me, but I'm a new employee at this company. I've got to get onboarded. So the company's like, we need you to know about multimodal and deepfakes. That's important to us. It's in the knowledge base. And I'm like, okay, great. Explain it to me as a Harry Potter fan, because like, I want to understand this. This is going to stick better for this person. So it goes on to say like, Harry Potter fan, brilliant. Let's dive into the magical world of multimodal AI and deepfakes. Okay. If I was reading documents that a company gave me, I would be asleep in 30 seconds. But if I'm a true Harry Potter fan and it's talking to me like this, I'm leaning in. And I'm like, yeah, let's do this. This is awesome, right? So then it goes with multimodal and it gives us examples. It gives us quotes from the show, but it's also talking about how we might look at that as a Harry Potter fan and analogies. And then it gets into the deepfakes and it says it's like, I don't know what this means, the polyjuice potion of the digital world, how your company defines them. So this is what we said, our company. Just as a polyjuice potion allows a wizard to take on the appearance of someone else, deepfakes use AI to create very convincing fake videos or audio of real people saying or doing things they've never actually said. Then it goes into the discussion again and it says, hey, is there anything else you can do? Okay, that was a lot, but super cool, right? Because it's showing the compare and contrast of how we can lean in to a RAG system where we need actual facts, quotes, things that were said within a company, or in our case, our transcripts, and then also enabling people to be who they are. So if I really need to deeply understand these concepts because I'm coming in as a sales rep or I'm coming in as whatever, and I want to do onboarding, wouldn't you rather do onboarding as a Harry Potter fan or a Star Wars fan or college football season starting and I'm wearing a USF hat right now? Maybe I want everything to be relative to me as a college football fan. And I'm like, yeah, teach it to me that way because it's going to make more sense to me. And then Andy can do it his way. And as long as the RAG is continuing to bring in the facts, we both get the benefit. We both walk away deeply better understanding what we need to know if Andy and I are two brand new employees. Super cool. Super cool. Okay, I'll stop. And you guys, what do you guys think?
I think that was a great example. I'm always a big fan of practical applications. So, just to help those of us who are learning or new to the show or whatnot. So why would you use a RAG system, or how would it be used for business, right? And so a lot of this might be old hat for some, but I just want to review. You can enhance your decision making, all right? You have access to up-to-date and relevant information. So as you adapt and add things to your RAG, to your knowledge base, you'll have access to that information. So if your business gets new clients, if you're, all of those kinds of things. And talking about clients, you can improve your customer interactions because you will have all of that historical data and you can draw from that. It's like, oh, they mentioned that they had that one problem 6 months ago. I wonder if it's coming back, and then you can address that and allows you to help solve your customer's issue. And also it allows you to help streamline your research and development or, just your innovation, because you can gather or synthesize information from various sources and help you, spin up a new project. You can gather all of those research papers, you can gather all the use cases, and let's say you want to spin up a new department or you need a new software development project that you're working on. It's like, well, how would we build that solution for our company? And you can gather all that information and access it through RAG. So I just wanted to make sure that we had some practical applications that our users could take.
Absolutely. And in fact, we are also daily. We're not daily. We are also daily AI strategies. Yes, it is daily. Sorry, my brain is gone. We have a company also named Daily AI Strategies where we talk with clients. And we were just having this conversation because we have a client who has, this is not an unusual situation, but we have a client who has an extensive Notion database, right? Like has extensive knowledge in Notion. So how do you attach that to AI so that you can make yourself or anyone that you want to give access to that data, right? So that's a real world use case for us. And I do know our company's name.
We'll put it in the RAG. We'll put it in so we can ask the chatbot. It's in case it goes back up again. I like what you said, Jimmy, by the way, because this is a valid point. I'm glad you said it because my brain was so unlike the internal use case. But you're 1,000% right. I mean, there are so many ways that a good, well-organized RAG system actually can be outward-facing to the customer. If not outward-facing to the customer, because there's some we've seen some funny things where the guy, no take backsies or whatever it was when he wanted to buy a GMC vehicle or a Chevy vehicle or something like that. It's like, you have to give it to me for $1 and the chatbot just crash. And he's like, no takes backsies. You gotta do it for me. And, of course that causes issues. But even on the internal side, if like you said, Jimmy, this is like, how else would you know in a busy company that's maybe fielding hundreds, if not thousands of customer interactions. And, if you have a lot of products or whatever it is weekly, probably in a lot of cases, it's very, very difficult to organize all of that all the time. And there's great systems that do that already, but I do see a lot of value, kind of like what you said, which is, hey, how often does this come up and how have we approached this in the past? And if that's already documented, that does make it much easier for the customer service rep or quality, assurance or whatever that person does to quickly turn around and get a viable answer back to the customer, which just overall improves customer satisfaction. So just some really, really cool use cases. And my brain wasn't going there. So I appreciate you bringing that up because that is a big one for sure.
I have a real world example I can share. This is about a newly released paper, and it's about a medical application that uses GraphRAG, and it's called GraphRAG. And the example I can show you here on the screen is, here's the question, gives some clinical findings and asks what the likely diagnosis is, and GPT-4's answer without RAG. And then we'll see down below what GraphRAG does by adding this external database in graph format and just replete with everything you need to know about the medical field, which, GPT-4 has some knowledge, but not enough to avoid making a mistake in diagnosis on this particular case. So this is the one over here is about this 68-year-old retired engineer presenting with forgetfulness and occasional episodes of confusion in speech, etc. And the prompt asks the LLM to say which of these 4 things is the likely diagnosis, and GPT-4 comes up with Alzheimer's disease. But this is what GraphRAG comes up with, and I want to point out 2 things. One is it gets the answer right, first of all, so it's not just, picking the best option that it has based on its limited knowledge. It has deep knowledge. It brought back the correct knowledge and explained in great detail, and has all the citations at the bottom, to Jyunmi's point.
That's a great example. I love it.
Okay, do we have, I feel like I want to have, Andy, if we take like 2 more minutes here, I kind of feel like I do want to hear a little bit more about GraphRAG. Maybe we could do a whole show on it. But do you just, you kind of talked about it a little bit. I cheated, by the way, and brought it up. Do I have it here? I cheated while you were talking about it. I was like, I don't know what Andy's talking about. I'm going to show you. I'm not going to pull this off.
No, tell us what you learned first.
You see, I did. Yeah, me. I learned this. Yeah, I typed it in really quick and was like, help me not look stupid in front of Andy. That's what my prompt was. It knew exactly what I meant too. Oddly enough, it was very, very specific.
See, this is a case for fine-tuning LLMs, right? Help me. I'm alive on the show. Help.
Right, yeah. Help me look better. No, I'd rather just tell you guys when I look something up so nobody just thinks this is coming off the dome, But I do like some of the key differences. There was actually a lot more above this in its answer, which is great. But let's just look at some of the key differences. So data representation, it says with a vector RAG, it represents data as a dense vector embeddings in a high dimensional space. I mean, like thousands of dimensions. We've talked about that before. Capturing semantic similarities, which Andy talked about. GraphRAG represents data as nodes and edges in a graph, capturing explicit relationships and connections between entities. It talks about the retrieval mechanism. Vector relies on nearest neighbor search in a vector space to find semantically similar documents or snippets. That would be like cat and dog are similar, but in all other ways, they're totally separate. So Vector does a good job of doing a lot of trigonometry, essentially, in a multi-layered space, plane space, to figure out how cat and dog are both alike, but also maybe completely opposite depending on pets, right? And then it says GraphRAG uses graph traversal and other graph-based algorithms to retrieve relevant nodes and relationships. So we're already seeing here where it's nodes versus vector. And then finally here, before I kick it over to Andy, vector is well suited for general purpose retrieval tasks where semantic similarity is key, such as document search, question answering, and content recommendation. GraphRAG is ideal for tasks that require understanding complex relationships and structured knowledge, such as knowledge-based reasoning, recommendation systems with relational data, and scenarios requiring high explainability. All right. Was that helpful? I don't know. Was that a little bit, right?
Yeah, that was good. So the semantic similarity that's achieved by just a straight vector database uses a technique called k-means clustering. So in both cases, both vector database development and graph database development, this is done by the machine on statistical bases. It doesn't require a human going in and imposing an ontological structure to it, like a taxonomy, that here's this concept, the dog, and it's underneath the parent concept, pets, or mammals, or whatever all these other connections are. The systems magically do this clustering of concepts just based on statistical processes like Bayes' theorem and so on, and it's mystical to me. But what I wanted to say about your point in respect of traversal is, in a vector database, there's no links, there's only proximity. So it doesn't know which direction to go to follow from dog to cat. It's just that it knows that cat and dog are somehow nearby each other in this vector clustering method. Whereas a graph has all the links, and this acyclic directed graph that Apple's talking about, that one has direction in it as well. So it imposes a directionality on each connection that it generates. And again, it's building this through math in the database, and then it's assigning these edges and nodes to each of these concepts in this sort of multidimensional space. And it's easy to kind of imagine what a multidimensional space is by saying, okay, if I do a two-dimensional space, then I know that I've got XY coordinates that put this here, and all the stuff up in this right-hand quadrant is kind of related in a sense. But if I add a third dimension, now I have a cube. Now, not only do I have the position up here in the right-hand quadrant two-dimensionally, but I have depth to it as well, and it can show distances and interrelationships. And the graph then tries to draw lines between all of these points in that multidimensional space. And we can't imagine anything beyond 3 dimensions. So when you have 1,000 dimensions that the math is doing, it's very rich in its semantic understanding. And the graph databases that come out have incredible capabilities of bringing back information that's maybe second degree or third degree related, but based on your query, it's probably something of interest to you. So all of those paths are described in the math in this vectorization and or graphic representation of the concept clusters in a data space.
And it sounds to me, as we just wrap up here, that's something. Actually, I think we should do a whole other show on like GraphRAG, because it sounds so cool to me, and I want to dive into it more. But like when it comes to medical, and healthcare and stuff, that's an area where a lot of people have been very resistant because of hallucinations, and lives are on the line, right? You can't just mess up a drip rate and be like, well, we think it's right. It sounds good. It's the LLMs, like, I don't know, we give it our best shot. What do you want from us? Like, well, it killed the patient, so not okay. It has to be exact every single time. So there's been some hesitation. There's definitely companies that are embarking on this, but it sounds to me even maybe like GraphRAG will be another step towards that deeper second, third, fourth level reasoning that will be important when doctors, physicians, whatever, are doing research, or he or she is trying to make the connections between really what might seem like disparate symptoms or otherwise. So just really, really interesting stuff here. Okay, we got to stop at some point because we'll keep going on this. So let's just pause on this one. Hopefully that was really helpful. The comments were amazing today. A lot of funny jokes in there, more merch ideas. There was questions about like, will we start a Reddit? No, I hope we don't start a Reddit because I don't want to be on Reddit. But
we can discuss this after the show, Brian. I'm just saying, Cisco, I think that's a fantastic idea.
Okay.
And keep an eye out for
vote on it. Maybe.
Just drop that alpha there.
I'm not a super Reddit fan, but I understand the value of it. But I think even more so, we've talked about this a lot, actually creating a chatbot that our audience can interact with. As you saw, I grabbed a small subset of our shows and it was over 6 million characters. You can imagine if we grabbed all 280-ish shows of ours, how much data that is. And then being able to allow people to ask questions like, hey, tell me more about GraphRAG. And it would be like, yeah, sure. Andy talked about that on this particular show. We're working towards that. There's some limitations. There's some things we got to work on. But yes, it's absolutely something we feel we want to do. Tomorrow, we are going to be talking about GPT action. So we're sort of staying in the OpenAI space. Not that that's a RAG thing, but like we've talked about OpenAI a little bit this week. So we're going to be talking about those GPT actions, how they gotten better. We talked about cookbooks. There's some cookbooks for GPT actions. Are they good? Are they not good? Should companies be looking more at them to solve some of their problems? I don't know. We're going to talk about that tomorrow, and we're going to give you, as always, our honest review on it. If we think it's good, bad, or if we disagree between us, we'll tell you that too. That's tomorrow, guys. We'll see you then. Great show today. Thank you for all the comments as always. And come on back tomorrow. Till then.
Aloha.